right, so welcome to today's lecture on the HTTP protocol. There's going to be some code in this lecture, but what I thought it would be fun to do is dig around a little bit lower level and just talk about how the HTTP protocol works, and just kind of play with the raw data a little bit, which I've always found fun when I'm learning a new protocol. So we're actually going to try and get some of the code sort of out of the way, client side, and just trying to interact with the HTTP protocol kind of by hand. I'm going to start by sharing my screen. Let me share my, I don't know, which one am I sharing? This one. Awesome. Okay, can everybody see my terminal all right? Here. Assume no response means yes. And let me open up the chat window before I forget. I will try and keep this thing visible and respond to questions in chat. But if not, just unmute yourself and yell at me. All right, so we're going to be using a tool that I found really helpful over the years in this lecture. And it's available with Brew, so you can Brew install it. It's called Netcat. You would just Brew install Netcat. You can install it locally if you're running OS X. I've already done that, and what that installs is actually a command that you invoke with just NC, which is short for Netcat. And what Netcat is, you might have guessed from the name, it works a lot like the cat command, or the idea is that it is in principle like the cat command, but it allows you to sort of like pipe data over the network instead of into a file. So, you know, with, so what would that look like in practice? So what you do is, yeah, I am recording. Thank you for double checking. I appreciate that. I have forgotten in the past. So what you do with Netcat is you can give it an IP address, some fake IP address here. That's not even a valid IP address, but get the idea. 200, that's probably valid. And optionally, well, no, a port, so an IP address and a port. And then you invoke the command and it just connects to that port. And then anything that comes into Netcat on standard input just gets sent over the internet to that port on that remote server. So it's a really fun way to interact with the HTTP protocol, which we know operates on port 80. We can hit sort of an arbitrary server. So for instance, we could go to google.com on port 80. And I hit enter and nothing happens because right now Netcat is just waiting for something to come in on standard input. And when it gets it, it'll send it along to Google's server, Google's web server listening on port 80. So, and this is what your browser does. When you type in www.google.com, it opens a network connection to port 80 on Google's server, and then it sends some data. And what your browser is going to send is a GET request. And with the HTTP protocol is just sort of a standard describing the text that should be sent in that kind of request and the format that the response is going to take. And the request is going to look something like this: GET, if you're doing a GET request, and then a space, and then some path. And if we just want to get like the root of the site, so we just want to go to google.com without anything after it, you just type get /. And then the protocol states that, oh, sorry. So I took too long to do that and the server timed out. Let's do that a little faster. Get /, and then a new line. And then as you can see, as soon as I typed that, a whole bunch of stuff flooded into my terminal. And all this JavaScript and HTML, this is what you would see if you did a view source on Google's homepage. So here's the get slash that I typed in. And then after that, everything else you see here is the response coming back from Google's server. And this first chunk is the sort of HTTP protocol headers. So the first thing it sends back is sort of the version of HTTP that it's assuming we're operating under, the version of the protocol, and a status code. 200 OK means that everything is good and a response is coming. And then the date and expires and content type. There's a whole bunch of different HTTP headers that get set in here. You can see down here, Google's setting a cookie in a header here. And then there's going to be an empty line followed by the actual body of the response. And that's where you see the HTML start. So real web pages are a lot larger and more complicated in real life than you want to parse through in your terminal like this. So what we're going to do is look at a sample Express app. So I've just created this little Express app here that listens on port 300 and just has a single route, right? Slash will return just the text hello world. So like super simple. It's not really even HTML. It's just a text string. And I'm just going to make sure that I got this thing running, npm start. And then in the console, now if I netcat this, so I can put in my own sort of local host IP address and hit port 300. And then if I do that same request, get slash, followed by a new line, that's the response from the Express server. So when you're building these sort of Express servers, that's what Express is doing for you, right? It's automatically printing out all of these headers for you, and then whatever it is you response send. And this weird little % sign here is just the terminal's way of showing that there's not a new line after hello world. There's just a null terminating character. That's the end of the request. So there you have it, HTTP protocol. And in real life, your browser is going to send a little bit more information than just get slash. It's probably going to specify a version of HTTP that it wants to talk about, that it wants to use, and possibly other headers like cookies and stuff like that, which we will see shortly. But the fun thing about HTTP and also SMTP, if it comes to that, is that it is just like a text-based protocol, so you can actually like peel back the hood and see exactly like these are the bytes being sent over the wire. It's just plain text. And so Express as a library, right, is using the underlying node like input-output libraries to open a port and listen, but then it's just doing text parsing. It's reading in and writing out text headers and sort of doing some of that work for you, so you don't have to write all that code yourself. So let's go make our server do something a little more interesting and set a cookie. So let's create a new route, new get route called cookie. And we'll get the request and the response. And let's see. And to set a cookie in Express, there's probably a couple ways to do this. But I'm going to use response.append, which will just append to the headers. And I will create a set cookie header. And I'll set the value to my cookie equals, and we'll set the value to blue. And then we're going to set a path for that cookie, which is going to be just slash top level path. Let's see. And then return some result. And how about this time we say, I set a cookie. Extra closing thing there. Okay, so now we got a new route.
What's your number?
I'm going to restart the server so it'll pick up those changes. And let me change what I'm sharing in my screen, actually, real quick.
Hey, I understand that, John.
So you guys can see this whole thing.
Hey, we're out here.
Okay, so you should be able to see my browser now. And so if I go to localhost port 3000 and I hit this, just the root here, we'll have hello world. And let's see, I'm just gonna make sure all my cookies have been cleared first.
619.
Let's do that again. So in my inspector here, you can see I've got no cookies. Hopefully that text isn't too small for you to see. And if I go to /cookies, cookie singular, I get the new page. And if I look at my cookies now, so my browser has picked up this my cookie. And it's got a value, which is blue, which is the value we set. And you can see that the path is set here. So that's how it looks in the browser. So what does that look like if we're just looking at the underlying protocol? So we're going to hit that server again, and then we're going to say get cookie. So this is where we're adding a path onto our get request to get a different route. And now in the responses that we get back, one of the headers that is included is set cookie. So this is all that the server is doing to set a cookie. It's just printing a little extra text in the header section that sort of directs the browser to save this little bit of information. A cookie called my cookie with the value of blue.
Okay. Hey, if you want to let her know.
Does that make sense? Any questions about that?
Give me about an hour. I'll call her.
So I don't know about you, but I think this is super exciting. I love it when you tear back the layer and like what's underneath is like, oh, that's actually really simple. Like, HTTP is not super complicated in its purest form. So you can start to see how like you could probably write a program that would like parse headers and set cookies and do some of the stuff that Express is doing for you. It's not actually that magical. So so that is setting a cookie. So the thing is that so let's do something else. So that's how the browser sets a cookie. What about let's call this print cookies. So if we create a route called print cookies and response request, one of the things we can do is take a look at what cookies the server is receiving from the client. And to do that, we are going to use an NPM module called cookie parser.
Hey, Trevor, I have a quick question.
Yeah.
Does it matter that on the print cookies, the response comes first before the request? Or is...
No, it does matter. That is a bug. Thank you.
Cool.
That is correct. Yeah. Thanks for catching that.
Yeah, totally.
You cannot just swap those around. That would have blown up in my face. Okay, so we're using this NPM module called cookie parser, and what that gives us is a middleware that will sort of look at the headers coming in from the client and sort of parse them out into a cookie object in the request. So I'm just going to do app use cookie parser, which just kind of installs that middleware. And all that does is it allows me to get the cookies by typing request.cookies. So we are going to response send request cookies. So now the page that we load should just print out whatever cookies we have. So let's see if that actually works. Restart my server and let's call print, go to print cookies. Can I get print cookie? Because cookies is plural. There we go. So there we go. That's our server, right, is just printing out the cookies. So that's what it looks like in the browser. But if we hit this in the console, we type get print cookies. So what we get here in the console is an empty object, right? There are no cookies. And the reason for that is cookies are sort of they're a protocol. They're built on trust, right? So the server can tell you. So for instance, we do this. We say we hit this route that's going to set a cookie. Oh, that's Google. That's not what I want. 7.0.0.1, 3000. So let's do this in slow motion. So we're going to get the COOKIE. We're going to get that cookie route, right? And the server says, hey, set this cookie. And the implicit agreement here is that the browser, the next time it sends a request to the server, is going to send that cookie back and basically say, hey, last time I talked to you, you told me that my cookie was blue. I'm just reminding you that my cookie is blue. The server actually doesn't keep track of what cookies it set on your browser. It has no idea by default, by the protocol. So it's incumbent upon the client to remember to send all the cookies back to the server. And so, new 27.0.0.1 3000. So what we can do here is we can do this get request again to print cookies. And then before doing an extra line here, we can add a header for these cookies, which is going to look something like this. It's just going to be cookie, colon, and then my cookie equals blue. Right? And then we get back, so then that goes up to the server, right? Like an editor, so it gets to the server, that header gets parsed by this cookie parser middleware and creates this, request cookies object, and then we just send it back and print it out. And that's what we're getting here. And just to reinforce this idea that the server is not actually keeping track of what cookies it set, I can create any cookies I want. The client can just invent cookies, right? I can just say, oh, there's also a cookie called XYZ that has a value of Fred, and there's one called cheese that has another value of blue or blue. And the server's going to see those and print them out. So that's how cookies work. It's really that simple. It's just the browser is sending back a header telling the client, the server sending back a header telling the client, which in most cases is the browser, hey, anytime you send me a request in the future, please include this information. And that's why cookies are used to track individual users, right? Because you could be logging in from your phone, from a different IP address. There's really no way to identify you as an individual when you switch locations or browsers. Well, especially when you switch locations. But if your browser is always kind of set to every time I talk to the server, I'm going to remind the server that my name is Steve. It allows the server to sort of have persistent sessions. So that's how we build sessions on top of cookies. So let's see, what else do we want to talk about? So that's cookie headers. Any other questions about cookies or how that works or anything we've seen so far? We're going to look at a couple other HTTP headers and how they work. But we can pause before we go on in case there are questions.
I had just a quick question about Express. I was curious, can you actually put multiple methods on app.use?
You can. Yeah, let me get back to my editor. Yeah, you can. So you could do this several times to install multiple middlewares like this. So cookie parser is one of them, but there's lots of them that can be used this way. Yeah, so you could do this multiple times. Does that answer your question? Is that what you were asking?
A little bit. What would it look like if I was just putting on, let's say, body parser, as well as app.use, so this, or as well as cookie parser, so this way it doesn't like overwrite?
Oh, body parser. I mean, I think it would look basically the same way. Body parser. I'm sorry, I'm scanning through the documentation just so I don't say this wrong. Right. So if you were so body parser, you're going to invoke something like this, right? I'm just pulling this out of their documentation. But you can do just one after the other and say cookie parser, body parser. And basically all these are doing is sort of the request that comes in from the browser is being passed in turn to each of these functions that you're using. And it'll sort of look at the request, do whatever it wants to with it. In the case of cookie parser, it's sort of like storing other information. It's adding this cookies attribute to the request, right? But then it just passes the whole thing on to whatever the next middleware is. In this case, like body parser JSON, that's going to parse the body of the request into JSON. So you can stack as many of these as you want. And they just sort of each get the request in turn and modify it in some way and then pass them on to the next. Does that make sense?
Yeah, that makes sense to me. Thanks.
Okay. All right. Any other questions before we move on? There's one in the chat. Could you explain what path equals / does when setting a cookie with response.append? Yes, I can. So cookies have a name and an attribute. A name and a value, which we're seeing here. My cookie equals blue, and then they've got a couple other attributes, and one is the path. So if we look here in the browser, we can say this my cookie that we set, and it has this path. The browser kind of shows it to us. And the idea between cookie paths is you might want to set a cookie just on like a portion of your site. So for instance, let's play with that a little bit. Let's say we wanted to create a new path called puppies. So we've got this puppies page on our site, right? And let's just print the cookies there too. Right. So if we do that, and we go to puppies, and oh, I'm doing my sending wrong. Sorry about that. Do send once, I think. Yeah. There we go. Let's try that again. Curses. Sorry, keep puppies. You have to go. One more time. Okay, so puppies is just going to print out the cookies. So it's getting that my cookie blue, because that the path is basically telling the browser which requests to include that cookie on. So if you set the path to /, the browser is going to include the cookie in its request headers for basically all requests on this site. Anything that includes / followed by anything at all. But we could also set a cookie here for, let's change this so we can just call this puppy cookie. And make it red. And this is just going to be, we'll change the path here to puppies, right? So now if we go in our browser to cookie, oh, got to restart my server. Okay, so now if we go to cookie, if we look at our cookies, we just have one cookie. What did you do wrong, Trevor? I wonder if I'm doing that set cookie thing wrong. Maybe that set cookie, if you're setting multiple cookies, has to all the cookies need to be in one header. Let me double check. It's been a while since I've done this.
Would it maybe only show up when you're in the puppies path?
Yes, thank you. That's right. That was the whole point of this example. Yes, someone's paying attention and it's not me. Right, so see that cookie is not showing up here. It got set, but let's see if that works. Puppies, right. So there's the puppy cookie. It only shows up in the puppies path. So now if we look here, you can see we've got two cookies on this path. In /puppies, we see the cookie from the root path, and we see another cookie from just /puppies. Yeah, that's exactly how that works. And so there's a lot of different reasons that might be useful. These days, you tend to think of a website as like you go to google.com and it's all Google. But there's other reasons you might want to namespace cookies, for instance, in like a shared hosting environment where you might have lots of different users at, for example, universities a lot of times. You might go to like, duke.edu, and then, every student at Duke has their own homepage, right? So there might be like a, duke.edu/students/Trevor, right? Where, if I was a student there, I could like host my own website here and I could have my own personal page and I might even be able to put some scripts in here. So you can have your web server enforce that like scripts can only install cookies that are prefixed with the path where the script lives. And that prevents, if you let students at duke.edu create scripts that set cookies, those scripts could end up setting cookies for the whole duke.edu domain. And even more seriously, those scripts could end up reading cookies that were intended for other parts of duke.edu, right? So if I go to some student's homepage on the Duke site, I don't want them to see my cookie that is used to log into, for instance, my financial aid portion of the Duke website if I'm also a student at Duke. Does that make sense? So it's just a way to like sort of cordon off cookies more granularly than just by the host name, which is going to matter in a lot of places where you have like lots of people hosting websites on the same domain. And I'm trying to think of like good examples of that these days, but a good one would be like HerokuApp.com, right? Where like your Heroku app has that sort of like general Heroku app domain. And so it's probably going to prevent you from setting cookies on the whole Heroku app domain or reading cookies on all of Heroku app, which would allow you to see like everybody's cookies for any Heroku application. Does that sort of answer your question?
We're looking at utilizing them on the remote site. But
Yes. Oh, is that?
Okay. Why is it important to set your cookies to your site? I don't recall having to do this manually. Can you expand on that a little bit? I'm not exactly sure like what part you're referring to when you say set your cookies to your site.
I know, because I mean, like, even just working on full stack apps or creating my routes, I don't recall having to actually set the cookie, because I saw that you did that manually, setting the cookie.
Right, yeah. So cookies are used most commonly for things like login and like user sessions. So most likely, if you've written an app that uses sessions and has like a login or logout, you're using some sort of a library to handle authentication for you, and it's setting these cookies for you manually. So a lot of times this is happening under the hood for the most common uses of cookies. An example of why this might be useful beyond authentication, or maybe like a simpler use case than authentication, would be, let me think if I can think of a good example of a website that I use that does something like this. So here's a good example. I think this is a good example. So let's go to Amazon. No, let's go to IMDb. So if you click around IMDb for a little while, we'll look at Rocky. We'll look at Rocky 4. Go to that page. And Sylvester Stallone. Let's look at another movie that he was in. As you sort of click around it a while, so you see here at the bottom of this page, it has a list of things that I've recently viewed, and I'm not logged into this site. So the only way that it really knows what I've recently viewed is that it set a cookie in my browser. And every time my browser visited the site, it noticed that it was the same user. Even though I haven't logged in, it just recognizes me because of this unique cookie that keeps getting passed back and forth. And so it allows you to sort of like customize the page, even short of like having users and authentication and login. You can just sort of track where people have been or information that they've given you in the past, and then use that to customize their page. So like a simple example of this would be a website that just asks us our name. Right? So, for instance, let's say, and these cookies are all based on just like, we're just hard coding values in here. You could easily like set these cookies values from a form. So you could have a website that sort of, asks you your name, and then on all the other pages, it can then greet you by name and say, hey, Trevor, blah, blah, blah. Does that kind of make sense? Does that answer your question?
Yes, thank you.
Okay, cool. What else? Other questions?
So the strategy for cookies, could it be either to set one cookie for the user and keep information about that user's history on the server, or else set multiple cookies for all the different actions that the user took, and not maintain any identity for a particular user? Could both of those have justification?
Yes, exactly. So yeah, the cheap thing to do, right, is just store all of the information you want to store about a user in a cookie and have them just keep sending it back and forth to you. The downside of that is that cookies sort of have a max size, and I don't remember what it is, but eventually the cookie will just get too big if you're trying to store too much information in it. And the other downside of that is that the cookie actually has to be sent across the wire, or across the Wi-Fi in a lot of cases, every time you request a page. So if you're requiring your users to send you a whole bunch of information in their cookie headers, it makes your page slower because that data has to go back and forth over the wire over and over again. And so that's one argument for just setting a unique ID in a cookie and then storing any information about that user you want, like in a server, just like indexed by that visitor ID. And the other thing someone else mentions in the chat is that cookies can be tampered with on the client side. So that's the other thing here. So the server is telling us, hey, send these cookies back to me every time. But there's nothing to stop us from going in here and saying, hey, I want to make my puppy cookie purple instead. And modern browsers now have, you can just go into your inspector and change your cookies. And if we reload this page now, the value of that cookie's been changed. So you kind of have a little less control over it server side if you're just storing the information in the client. So that's another argument for, keeping your data server side. And you'll also see a lot of sites will actually encrypt the cookie to make it tamper proof. I can't go in and like change the value of my cookies because it's encrypted. And the server will sort of like, encrypt something, send it in a cookie, and then when that encrypted string gets sent back in subsequent requests, the server can decrypt it and interpret it. It's a really good question.
So also, how would you compare the functionality of using, when forms are being used, using cookies to keep track of information entered in forms versus using hidden fields?
Oh, interesting. Yeah. Yeah, I mean, it's two very different, two very similar ways of doing the same thing, especially when you think of the HTTP protocol, right? You're either, if you have a hidden field in a form, then that's going to get sent in the like post data portion of the request, as opposed to a few lines earlier in the headers of the request. So like performance wise, it's pretty much the same. The data is just getting passed back and forth over the wire. It just depends like where in the request it's being sent. Yeah, I'm trying to think. It's been a while since I've needed to implement something like that by hand. And it probably depends on like the constraints of the application that you're building and like what you're trying to solve for, whether there's a compelling case to be made for hidden fields or a cookie. Again, the cookie gives you a more tamper-proof option potentially. If you're just storing an ID and then like keeping track of that session server side, or storing like a encrypted session in the cookie, there's just less chance of people messing with things. I don't have like a real hard and fast rule about like, oh, always use hidden fields or always use cookies in this or that case. I have to say, I've definitely, it's been a long time since I've used hidden fields for something like that. But it's also, I've spent a lot of my career writing more back-end oriented code. So it could be that there's still good use cases for using hidden fields to persist information, but it feels a little bit like a workaround that we may not need these days, especially with the other kinds of like browser storage that there are in addition to cookies nowadays.
Great, thanks.
Someone's asking, when you put the setting for not getting cookies, how does your computer stop them? So that's what's really interesting. It's actually really easy because setting a cookie is just the server saying, hey, I'd really like it if next time you send a request to me, you sent this cookie back to me as well. And so your computer stops the cookies by just ignoring those cookie headers and saying, oh, you're trying to set a cookie. That's nice. I do not accept. It just doesn't save it. And it doesn't then include it in the response. So for instance, we're our own browser here with this little Netcat utility, right? So we can, get the cookie URL, and we can see that the server is trying to set these two cookies, but it's entirely up to us whether to send those in the next request. So the very next request I can issue is get /. And if I don't include those cookies in my response, the server is never going to see them, not going to know they're there, not going to be able to print them out when I hit the print cookies URL, right? It's just going to get an empty object. So yeah, it's the interesting thing. Cookies are sort of talked about as this like insidious thing, and like servers are like inserting information into your computer without your permission and all these things. And it's actually like, it's an opt-in. It's just a protocol. It's a convention that by the protocol, if the server sends you this information in this way, your browser is going to voluntarily send it back. So it actually turns out to be, from a technical point of view, really easy to turn off by just telling your browser, like, no, do not respond with any of those cookies that were attempted to get set. Is there a way to bypass it in your code if someone blocks it? So there's not a way to force someone else's computer to send you information it doesn't want to send you. That's kind of a blanket statement. Like, surely there's there are ways if you hack into their computer, right? But just from like an HTTP protocol perspective, all the server can do is add cookie headers to their response and hope that the browser will play along and pass those cookies back in subsequent requests. But there are, if your goal is to like uniquely identify that user, and that's what you're using cookies for, there are other ways to do that that probably are, you know, fall somewhere in the range of ethical to completely unethical, right? But there are ways you can look at the IP address that the browser is coming from, and you can use that to try and identify people. There's also all this other information that clients send. So you'll notice, well, maybe we didn't notice. Let's see. Clients end up sending a whole bunch of headers. So like so let's flip this around. So the other cool thing about Netcat is that you can set it up as a server and listen. And I just have to remember how to do this, but I think I can listen on port 3001, right? So now Netcat is just a server listening on port 3001, and any data that comes in over that port, it will just print out to the screen. So let's see what happens when we hit 3001 with some path. MongoDB over HTTP. Oh, sorry. Let's try a different port. Let's try 8008. And I actually have to start that command. Okay, so now Netcat's listening. So this is what the request from my Google Chrome browser looks like. So we can see the path that was requested. And then there's this thing here, user agent, which is a very specific user agent, right? It tells the exact version of Chrome Safari that I'm using. A lot of times there's so much information in these user agent headers, you can actually start to uniquely identify people just by the exact version of the browser that they're using. It doesn't look like it's doing it here, but I think there are some browsers that will like actually report in the headers what plugins you have installed. And so you can end up getting like a very unique sense of like which user is which just by looking at the headers that are getting sent. I would say that's probably like verges on the unethical side where you're sort of inferring someone's identity when they're not really intending you to. But there are sites out there that will do that sort of thing to try and get a sense of like users, even if like cookies are turned off, for example. Yeah, browser signature, yeah. And even different browsers will sort of like, these accept headers are in a certain order here, and I think different browsers will send them in different orders or have different combinations of them, and there are ways to sort of infer things from the headers. Okay, so let's go back to this example and look at a couple other things while we're doing this. Okay, so, oh, did I miss a question? Sorry, there's a lot going on here. Oh, sorry, yeah, there it is. If you're using a module that will encrypt the cookies for you, should you still check if they've been changed or the encryption safe enough? That's a good question. the encryption should be safe enough. If you're using decent encryption, it's a really hard problem to break that encryption and change your cookie and re-encrypt it. So if someone is able to like break your encryption on your cookies, you probably have bigger problems than the fact that they're changing the values of their own cookies. So normally encrypting it is sort of the best way to ensure that the data hasn't been changed. Yeah. Because if they can change the encryption, it could be a little hard to check if they've changed the data, right? Especially if the only thing you're storing there is, so if you're storing the data server side, sorry, what I'm trying to say is the only way you could tell if the data has been changed is to compare it against what it should be. And if you're already storing server side what the data should be, then you don't need to be storing it in the cookie at all. The only thing you need to store in the cookie is like the user's ID. But then on the flip side, if the only thing you're storing in the cookie is the ID and it's encrypted, then if somehow they were able to break your encryption and change the ID in the cookie, you wouldn't be able to tell that they had changed it. It would just look to you like it was a different user coming in, which is a serious problem, right? That would allow someone to, if I can break open my cookie, decrypt it, and change the ID to someone else's ID, it basically allows me to log in as that other person on your site, which is a massive security problem. The good news is that if you're using, industry standard encryption, that shouldn't be possible to do, short of having a really massive supercomputer or getting really, really lucky. Good question. Okay, so let's look at another header before we run out of time that I think is interesting. So one of the things that gets set in the header is something called, there's a header called ContentDisposition. That's useful for, let's do this. So let's say we want to post files on our sites we want, users to be able to download a file. So maybe there's you might have an app that generates reports. So someone hits a URL and you sort of generate like some sort of a spreadsheet report for them, right? So say we had some report endpoint. And make sure we put these in the right order this time. So let's say we had some report and, it's probably something that takes a while to generate, but just to fake it out, we'll say it's just a report that has, it's like a sales report, right? So maybe it's some sort of a comma separated report that's going to have purchases and revenue and something else we want to track besides purchases and revenue, which is like refunds, right? So we're just going to make why is this not working? We're going to make a comma separated file here. So we're going to say we have 1,001 purchases and revenue was lots of money and there were no refunds because everybody loves our stuff, right? So you can imagine this report being, 8,000 lines long, potentially, but this is a real simple version. So let's go and look at this thing. So if we do this, what do we call this? Report. Go look at the report. So we get this thing here, but it's not super useful. It's just like printing the text in the browser when really the use case we want is like we want someone to be able to download this report and open it with their spreadsheet application, right? Because this sort of like comma separated values with new lines is actually something that like Microsoft Excel will open up as a spreadsheet. So the way you tell the browser to, instead of displaying the text in the browser, to actually like prompt you to download and save a file is a header. And the header is called content disposition. So if we add this append content disposition, and then we can set the content disposition to attachment. And we can even tell the browser a suggested file name to use when saving the download. So we could say file name equals sales report dot comma separated value CSV. And I'm just gonna comment this out real quick so that we can first see what this thing looks like the first time. So if we just go and get port, report comes in like that, right? Uh-oh, my new line got eaten. Where's my new line? Maybe I need to do that. Let's try this one more time. So get report. There we go. Well, my new line's getting munched, and I'm not sure why. Oh well. Oh no, there it is. I'm sorry, it's on 2 lines. I just can't read. First line, second line. So that's what it looks like in the first case, right? And then if we just add this content disposition, we'll see that the request, once we restart the server, the response is going to look almost identical, right? The text that comes back is the same. The only addition is this content disposition header. But when we run that in the browser is configured such that when it sees that content disposition, nothing happens. All right. Let's see, CONTENT disposition attachment.
Oh, that's good going.
Well, that is unfortunate.
With the invoices being sent back down there from TSI, how's it shaping?
Oh, there we go. Sorry. Had to do a hard reload because the browser was caching the headers probably. Let's try this one more time. Report. Right, so now when we hit it, we get this like nice download box. And you can see the save as is pre-populated with that file name that's in the header. And so if we save that to our downloads folder, we get this nice behavior where it downloads the report and then the user can open it. And because it's a comma separated values, my numbers will automatically open it. So anyway, there's another fun header with HTTP. And there's a lot of these for setting cookies and for setting content, not only content disposition like this, but also content type. You would set a different content type if you were returning a JSON data versus HTML data, that sort of thing. And then the last thing, this is probably obvious from what you've seen so far, but you know, all of these have been GET requests, and other types of requests like POST requests should work pretty much the same way. Actually, let's do this. So let's add a couple more routes here, and we're going to add a GET route called foo and a POST route called foo. So we've added these 2 new routes, right? And the only difference is the HTTP action that we're looking for, GET versus POST. And so if we restart the server, you know, if we hit that in the browser, right? The browser by default is doing GET requests. And in the console, if we use Netcat,
DAK resources.
same thing, right? That works. And to do post requests, it's as simple as just changing the verb in that first line of the request.
Right, I do.
And that hits the post route. And so that's all Express is doing when you're setting up get routes versus post routes or put routes. It's just parsing that very first word in the HTTP request to figure out what action the client is trying to do. And then it's calling the right function in your Express app.
Okay.
All right. Are there any questions in the chat that I've missed?
Okay.
Did we get to this last one? If an encrypted cookie is safe enough, what does Passport do that is so much safer? Is it just the convenience of setting, checking the cookies, and that logged in function that comes with it? Yeah, it's. I'm not familiar with all of the functionality that Passport provides, but in general, that's what a library like that is giving you. It's just you've got to get some encryption algorithm to use and encrypt the cookie and set it automatically, and then read the cookie when it comes back and decrypt it, and it's just doing that work for you. It's probably a lot less magic than it seems at first, what it's doing. A lot of these things, a lot of these little libraries you use with Express are super handy, but they're not actually doing anything that's that magical, which is why I wanted to do this lecture, just showing you the raw protocol. This stuff isn't that complicated. Y'all could probably write some of those libraries that you use that seem real complicated. Like the basic functionality they're adding you is just code that you could write. You just don't want to write it over and over again. And they're also providing sort of the nice thing about using a library is that you're probably finding the best way to do something because it's been looked at by lots and lots of people and it's been used in a lot of places. But a lot of the basic functionality is stuff that you could write on your own. It's just not worth the time because, once 28,000 people have implemented encrypting a cookie and setting up a session, it just doesn't make sense to write that code again. Just pick a good way and put it in an NPM module and be done with it. But yeah, mostly it's just convenience. And also for things that involve security, there's so many easy ways to get it wrong with encryption. So especially for things that are implementing encryption algorithms, you want to go with a well-tested library just to have a higher confidence that the thing works and doesn't have some weird security flaw in it. Once it's being used by thousands and thousands of people, the chances that security flaws didn't get caught go down significantly. Cool. A lot of good questions today. Anybody else have questions before we wrap up? We got a couple more minutes. Code you wrote, yes.
We're
yes,
also working
yes.
on a security
This code
project.
here.
Jacksonville. We're teaming with a company here.
Anything in particular you wanted to see?
But they're,
You just wanted to make notes.
And they're based in Hawaii.
What are some common headers we need to be aware of? So the set cookie is kind of one of the big ones. There's also a content type header, which kind of cues in the browser whether it's going to be receiving HTML or JSON or plain text. So that's one you may need to be aware of that may come up. In this example where I was sending a report, it sort of worked the way that I did it. But for instance, if you had an application that was maybe going to serve some sort of an image file, you're going to set a different content type for image files than for plain text files to tell the browser that it's going to the data it's going to get back is going to be an image, not a text file.
You make sure that you get the hours.
Content type, set cookie. This content disposition is a handy one to know about. And other than that, those are probably the biggest ones to worry about for now. There's also there are caching headers, and this isn't something you'll probably run into real early on, but there are caching headers that will tell a browser how long a page can be cached before it needs to request it again. And it's not as useful for individual browsers, but they're used by what are called content delivery networks to sort of cache pages closer to the source. So for instance, you know, the server that serves the Google homepage, right, might be in you know, Silicon Valley somewhere. But if you're trying to hit a Google server from Siberia, you're likely not making a request all the way to that Silicon Valley server. There's probably a server closer to Siberia somewhere that is sort of intercepting that request and has possibly cached the Google homepage that you're requesting. So there's a lot of like intermediary servers out there between you and the server you're requesting data from that may or may not sort of cache data just to make it faster. And so there are headers that control, that allow a server to specify how long a page is safe to be cached. You know, so some pages you would never want cached because the content is dynamic. It should be different every time. But some pages, often like a website homepage or something like that, can be cached. And so there are ways, there are headers that you can set for what are called cache control. So you can Google cache control headers and content delivery networks if you're really interested in those topics. The headers we covered today are probably the most common ones you'll see. And a lot of it is mainly, again, there's a lot of common modules and libraries that manage this stuff for you. So really just having an idea of like what's going on under the hood, it can help a lot. And it can help you sort of know how to better use those libraries or better understand what they're doing. Yeah, cache control headers and content delivery networks were the two things I was mentioning. And someone's asking, what does OAuth extend to Passport? So OAuth is a protocol for like single sign-on. So it's like another protocol on top of HTTP, on top of cookies and all this other stuff that provides like a common way for sites to provide single sign-on behavior, sort of like the, you know, login with Facebook, login with Google. Those are implemented with OAuth. And so it's just Passport, that OAuth, and I'm not familiar enough to know if there's like a specific like OAuth plugin for Passport that you're referencing, but that's what OAuth is a protocol for like single sign-on. And there are going to be a lot of libraries out there that that provide code for like implementing OAuth in your application. Does that answer your question, or am I way off on that? Okay, awesome. All right, well, we're 4 minutes over, so I'm going to wrap up, and I'll put this video up online as soon as it's downloaded and encoded and all of that. Thank you all for showing up and asking good questions, and I will see you around. Have a happy Monday.
I wanted to say one last thing.
How's that?
Oh, no, I just want to say I posted a link on the slides for the anatomy of HTTP.
Oh, great.
Before, it's actually really great. Nice. Just FYI.
Awesome. Thanks for that.
You're welcome.
Check that out. All right. Have a good day, everybody.